Hello and welcome to another episode of the PPM Historian, where I take project management methodologies and apply them to historic events for your entertainment. And today we're talking about a very wobbly bridge, the Millennium Bridge in London. Can you believe that it's already been 20 years since we celebrated the Millennium? In the year 2000 in London, there were a number of big construction projects that were taking place. They weren't all successful. I'm going to talk about one that wasn't. That one being the Millennium Bridge, which was the first new bridge over the Thames in over 100 years. The Millennium Bridge had one characteristic that set it apart from all of the rest of the bridges in London. It was wobbly. This 325 metre long pedestrian bridge has become one of London's top tourist attractions, mainly because of the fantastic views you get of St Paul's Cathedral. I'm not saying that St Paul's Cathedral is great to look at. Personally, I think it's good to look at, but if you're going to look at it, you need to do it from the Millennium Bridge. The bridge was a collaboration between several different architects, those from Foster and Partners, the Arup Engineers, and Sir Anthony Caro. However, this collaboration did start out a bit wobbly, as the bridge they initially delivered had a tendency to move in ways that people weren't necessarily predicting. Good for a bouncy castle, not great for a city bridge. It was like a wobbly pudding, or a jelly. It was like a jelly. It was a jelly bridge. It was opened in the year 2000 by the Queen herself, and by that point the project was already 2 months overdue, and I'm willing to bet that the Queen was not happy that she had to change her scheduling multiple times. Her diary was probably covered in scribbles. Unacceptable. Now, the day the bridge opened, it was very busy. They had up to 80,000 pedestrian visitors, and at one point there were nearly 2,000 people on the bridge itself, and that is when it all went wrong. It didn't collapse, just wobbled. Now, it was at this point that the project director of Arup got a phone call that I'm sure he neither expected nor appreciated. It had one simple message: we have a problem. And when he finally got to the bridge, he realised just how much of an undersell that message was. His first thought was, this can't be happening. But it was happening. The bridge, all 690 tons of it, had started to sway. And it swayed to such an extent that people on the bridge actually had to throw themselves in the opposite direction of the motion in order to keep their balance. It looked like Gladiators or Takeshi's Castle. But that only made things worse, because the more people moved around, the worse the motion got. Imagine being on a boat during a storm. If everybody gets up and starts moving around, it's only going to add to the erratic behaviour of the boat, and the same principle was true here. And in the centre of the bridge, the deck was actually moving up and down by 70 millimetres, which is 7 centimetres, or this many inches. Now, initially, they did just simply try to limit the number of people that could be on the bridge at any one time, but that didn't really work, and it wouldn't really work long term anyway. And it was at that point the decision was made to close the bridge after only 2 days of operation. They got 2 days out of it. 2 days might not sound like a long time to you, but personally, if I built a bridge, I'd be pretty happy if it lasted 2 days. You may be asking yourself, what does this have to do with project and program management? But I'm going to address that. Today we're going to be discussing the Prince 2 quality theme, which was obviously severely lacking in the production of this bouncy bridge. Unless it was a bouncy bridge. If they were trying to build a bouncy bridge, then the quality theme was perfectly implemented. Let's step back a little bit before the opening of the bridge to consider what might have gone on from a Prince 2 perspective. So as I've just said, one of the key themes in Prince 2 is quality. This is all about the product of a project, making sure that it meets business expectations and enables the realisation of desired benefits. And obviously the product here is the Millennium Bridge. An important aspect of the quality theme is the project product descriptions and product descriptions. The project product description refers to the overall project output, which in this case is the Millennium Bridge. And this includes quality expectations, acceptance criteria, and methods. The product description, on the other hand, describes the purpose, composition, derivation, and quality criteria of each product. For example, all the different parts that were needed to actually build the bridge and which work packages those parts fit into. And then in addition to that, we also have quality control. Now this is achieved by implementing, monitoring, and recording the quality methods and responsibilities that are described in the quality management approach and the product descriptions. In other words, checking that the delivered products actually meet the quality criteria that was agreed beforehand. You haven't requested a trifle and received cheese, because who wants cheese when you fancy a trifle? And it seems like it was in this aspect that something severely went wrong with the Millennium Bridge. Don't forget the wobbles. The design of the bridge was an important part of the project product description. After all, this design was a result of a competition, so it was the look that won, not the engineering behind it. This design was referred to as the Blade of Light, so everyone working on the project needed to get it right, because they had to deliver something called the Blade of Light. That's pressure. Major pressure. The bridge wasn't supposed to have any tall supporting columns. Instead, lateral suspension was used, which meant that the supporting cables were underneath the deck of the bridge, which was apparently innovative at the time. Sometimes there's a reason people don't do things. Quality control. It looks like all of the engineers did all of their necessary quality controls, and they tested every element of the bridge. They did all of the calculations, safety assessments, risk assessments, and they even tested the bridge in a wind tunnel. As a side note, that's because after 1940, when the Tacoma Narrows Bridge collapsed, people learned a lot more about how wind impacts a bridge. And if you've never heard of that, I'd Google it and watch the video because it's very dramatic. I can't put it here because copyright, I imagine. Now, going back to the Millennium Bridge, the engineers also assessed the vertical pedestrian excitation, which is the vertical vibration caused by pedestrians on the bridge. I didn't know they had a name for that either. During these tests, they actually used more force than was required. And believe it or not, all of the vertical movements that took place on the opening day were within British standards, i.e. the bridge building codes. There's a bridge building codes. The other BBC. Ultimately, it wasn't vertical movement that was the problem. What actually led to the closure of the bridge was a phenomenon called synchronous lateral excitation. Lots of big words in this one, isn't there? This meant that all of the pedestrians that were crossing the bridge were slowly adjusting their movement in order to fit with the motion that the bridge was already experiencing. And that just made everything worse. And apparently this was a phenomenon of which little was known in the engineering world. That's not to say that there hadn't been other bridges around the world that have experienced this phenomenon, it's just that the engineers at Arup weren't familiar with it, and there hadn't been any research published about it, so the engineering world was simply unaware. This also meant that any bridge with its own natural frequency and large numbers of people going across it could begin to sway in the same way. Sway in the same way? I'm a rapper. So was the issue here that those engineers that had worked on all those other bridges that have experienced this phenomenon simply weren't transparent, or could you say that the Millennium Bridge engineers simply hadn't done enough research? Well, we can't say for sure either way. What we can say for certain is that this is a difficult quality scenario. So for now, let's look at quality management and the actual result of the project. According to Prince 2, if you don't conduct proper quality management, you can end up with overspend and poor quality results. And essentially, we had both here, because you had a very expensive bridge that didn't function effectively as a bridge. And those problems meant that additional work was required in order to stop the motion of the bridge. And it was finally fixed through the use of additional dampers. Do I know what a damper is? No, I don't. Naturally, this engineering, construction and planning work all came at an additional cost. The project was already £2.2 million over budget by the time it was initially opened in 2000, when it was still all wobbly. But the work that had to go into stopping the motion cost an additional £5 million. So that puts us £7.2 million over budget. So from a budget point of view, the bridge did not meet business expectations. But that wasn't all. The project was also hugely embarrassing for the Arup engineers and everyone else involved. It doesn't exactly score you many points for your reputation when you're somebody who designs bridges and the last bridge you designed behaved more like a river than it did a bridge. People will look down on that. Now, initially, they announced that the bridge would be closed for about 6 months after its initial opening. And that was a poor estimate because it didn't reopen again until February 2002, which is a few months more than 6. So in conclusion, we now know that the motion of the bridge wasn't caused by the design of the bridge itself, but rather by the behaviour of the people using it. However, the big question that remains is, should the engineers working on the bridge have anticipated these issues? While I'm not an engineer myself, I think I can speak on behalf of a lot of people who were very shocked to see the bridge behaving in such a way that bridges don't normally behave. It was like seeing a politician in a tracksuit. So we have to leave it there, but now we know how quality management and quality controls could have had such a positive impact on the building of the wobbly bridge. But the good thing is the bridge building codes have now been adapted to take synchronous lateral excitation into consideration for future projects. And that, hopefully, is by far the most complicated sentence I'm ever going to have to say on this YouTube channel. Like and subscribe. I'll see you next time.